So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This video 307, and in this video I want to make a quick example again for this R-value reference, which we already talked, and the reason for that is because if you use it wrong you will make here many mistakes. And what I mean with use it wrong, I said here if you use the std_move function, then it will convert it to an to an R value, and you can use here this R value reference. But there is a problem, you can make it wrong, and I will show you this now here in this example. So I just copied the same code what we have here to this code here, and here are the two functions. So I have only two. One is the L value reference and the other one is the R value reference. And now we will see what we can make right or wrong. First of all, here's the example. They started here with an R value reference, but we have a name, so the whole expression becomes an L value. They called it, and here it calls the L value reference. And the confusing part was here, intuitively you would think it is calling this one. Why intuitively? Because most time a programmer is watching the type and said, it is this type, when I call it, this type will call. And this is the first thing what you have here to really remember when you see that. That in value categories, if you see a name, it will become all time an L value expression. So this is let's say the easy way to thinking. So if you see it's a name, the whole expression is an L value, the compiler say, okay, I call the L value binding here. So, but the question is now, wait a minute, here we use this std_move, and I told you this std_move can convert an L value expression, and this is a L value expression, to a R value expression, and specifically here depends on X value or PR value. But then this is okay, but now what can we do wrong here, or what can we do right? Let me make here another example to make this clear. So first of all, we start with an example. I create here x2, have 5, the whole expression is an L value expression, okay. But then I said, okay, I want to convert this one to an R value reference. How we do this? We know two ways now. One, this way we already know, it's a static cast, and then I put in here a X, and here the type which I want, and this one it's converting my x2, and here I have to write x2, converting my x2 to this casted x. Or the second way, and this is the new way with this move semantics, you can use this std_move, and it is do exactly the same thing here. But when I told you this one with this std_move here on top, I told you it is converting an L value expression to a R value expression, right? So, and okay, I did it here because I used now here this std_move, right? And I assigned it to this one, and now I can call this one here. Let's call this one here fcasted x, and what we expect now, what happened, let's make here a debug to see it, start it, and we get what? An error. Not an error, the wrong function call, what we not expected. Normally, why not? But because look what we did. Here's a R value reference, right? I told you this std_move is converting an L value expression to an R value expression, right? But look what happens here real, and that is the mistake what can be made very easy. And again, we are using here std_move here, but then we are binding it to a name again. So when I told you here in front, if you see any name, so any name here in code, the whole expression will be an L value expression. So here I used std_move, which is indeed really converting an L value expression here, this x2, in an R value expression. But the problem is what? The problem is it's only doing here in this place. After I use it a binding and assigning to a name, this expression is no more an R value. It is an L value expression. An L value expression will call our L value reference. The compiler said, okay, I found a name, L value reference I will call. So this, I hope you see it. And the easy rule what you have to remember with expression is when you see a name, it will be all time the L value expression. But the question is now, wait a minute, you told us std_move is converting the L value expression to an R value expression. How does this work then? Right. And again, let's repeat this a little bit. std_move indeed is converting an L value, this one here, in an R value expression. But I told you only here without a binding to a name. So what does this mean? If you want to make it right, then you have make it like they did. They call the function and then they use the std_move x directly as a argument. And here, this x here, this was an L value expression. This one is an R value expression. And again, why is this an R value expression? Because this one here is bound to nothing. It is just computed and it is a temporary value right now at this point here. The same goes here. So it is std_move is again computing something. So it says, okay, I change you to an R value expression, but it is just at this place here. So after this one you bind, it's no more here. This one will more or less destroy. This one has a binding to this R value, this x2. So think about like that. So if you see a name, then it's an L value expression. And the same thing goes here for our to make our example right. You have just to call it with the function. Again, you can use std_move, and std_move is the same like the static cast, which we already know. You can call also as static cast. It's the same. Let's test this. If this is true, here's the other version with the static cast. Let's test first the move. If I'm right, perhaps I told you only crap. And yeah, let's see. It's called indeed the R value reference. So again, why it's calling again the R value reference? Because this one is bound to nothing. It is just calculated here and it's an R value reference then. And the same thing goes for static cast. I show you this one too, because these both move and static cast are equivalent, which means when I start this one and you call the static cast, and we will see it is jumping to an R value reference as well. This one can cause big problems, and why I'm repeating this one, because we need this later for move semantics, move assignment operator, and you have to see this difference here. And the difference is, again, because it's so important, careful, not watch just the type. It is an R value reference. When you see it has a name, it is probably an L value reference. It is just an R value reference, or if it's just created here or just created here as a parameter, you can see it is, this parameter is bound to nothing really. It is just created here at this point. Anyway, I hope it helps a little bit. We need this soon in our constructor, move constructor and move assignment operator, and in our examples. And in the next video, we go to the initialization of all these references. See you there. And like all time, if you have any question, write in the comment section. See you in the next video. Bye, good luck, and have fun.